Hello everyone, this is Udaditya from TechSpark. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. In today's session, we're going to talk about Hadoop Cluster and its key components. But before jumping into Hadoop Cluster, let us talk about distributed ecosystem, how it looks like and how it works under the hood. Let us take a scenario where I have been assigned a work where it takes almost 10 hours to complete. Now to reduce the workload, I assign one more person. Now combining the two of us, it takes 5 hours to complete the same task. Suppose I want to reduce the workload further, so I assign two more people. Now it takes 2.5 hours each of us to complete the same task. So you see, by distributing the workload, we can achieve the goal in 1/4 of the time that was initially given. In the world of big data, storing the large amount of data in distributed manner helps us the same way as I just presented in the example. Suppose I have petabytes or exabytes of large amount of data that I need to store. Obviously, storing the same amount in a single machine would be a tedious job and it will be heavily loaded. To achieve the same goal, the way we do it is we present an ensemble of nodes or machines which are termed as the community hardware. And this assemble of the nodes of the commodity hardware are known as the cluster. So basically, these nodes are nothing but each and every machine. A machine consists of some amount of RAM, hard disk, CPU cores, and whatnot. So if I have, say, petabytes of data that I want to store, not in a single machine, but I want to chunk it into different blocks and distribute them across the cluster in different nodes. In that case, it would be much easier for me to load the same data across the cluster without having to load any of the specific nodes. With this idea comes the Hadoop cluster. The Hadoop cluster works in a similar way where there are two different kinds of nodes. Before jumping into the structure of the nodes or the types of the nodes, one must understand the Hadoop cluster works in a master-slave strategy. A master-slave strategy means there would be one master and there would be several slaves who will be working under the instruction of that master. Now there are primarily two kinds of nodes that consist in the Hadoop cluster. One being the name node, the other one is the data node. NameNode is the brain of HDFS. It doesn't store the actual data but holds the metadata, the information about where each part of your data resides. The slave nodes, this slave nodes on the other hand, store the actual data in HDFS. They handle read-write operations as instructed by the name node. So why the name node is called the master and the data nodes are the slave? Obviously, the name node is not containing the actual data, whereas the data node has the actual data. Even though the name node doesn't have the actual data, it contains the metadata of the data that is residing in the data node. Now, what does this metadata means? So before coming to metadata, let us understand how the data is put into data nodes or stored into the data nodes. Whenever a client makes a call to load some data into the data nodes, in that case, data first will be segmented based upon the block size of the Hadoop cluster. Also, it will create different replicas based on the replication factor of the same cluster. Now, once the data is divided into small blocks, they will be stored across different nodes in the cluster. Also, the replicas for each and every block will be stored into other different data nodes. Now each and every block of the data will be stored in one single data node. To get the information of that data node where that particular block of data is stored, NameNode is there to help you. NameNode will fetch that information, that what block of data resides in which node, and also the replica, and it will get that information and put to the client. Once it is presented to the client, it is easier for the client to get that information of the data from the data node. Now you must be understand. Now must be wondering, why do we need the replication and what is the need of the block as well? In the previous example, I was saying that if I want to put a huge load of data into a cluster or across all the nodes, it is better not to overload one single node or one single machine. If I chunk it into different blocks and put them into different machines, it's obviously easier for me to put the data and also retrieve the same. So that's how the block size works. Now, if I talk about replication, suppose if I have one block in one machine and the machine goes down, then I completely lose the data, right? But if I have the replica of the same block into two different other machines, in that case, if the one machine goes down, I have two other machines to take care of. So that's why the replication comes. And this phenomenon is known as the fault tolerance in the Hadoop cluster. So again, coming back to the master slave architecture, NameNode is called the master because it retrieves the information of the data from the data node. Now let me give you a simpler example. So there is a project and I am the client of the project, right? So I need to get the information or the update of the project. So what do? Do I reach out to the employee or the team members, or do I reach out to the manager first? For obvious reasons, I'll be approaching the manager first. So I ask the manager what is the status of the project. Now the manager in turn will reach out to its team members to ask the status of the project. So once the manager gets the information of the update of the project that's been going on from the team members, then the manager can present it to me. Similarly, me being the client, if I try to do a read-write operations on the Hadoop cluster, I will connect with the NameNode first. The NameNode will retrieve the information to what nodes or to what nodes or to what blocks my data is residing. In that case only, I'll be able to retrieve the data. If I try to load some data into Hadoop cluster, also the NameNode will come into action first. NameNode will allocate and assign the data nodes where my data will be put into separate blocks. And based upon the replication factor, also in what nodes the data will be replicated into, that will also be decided by the NameNode only. So this is the reason the NameNode is termed as the master, whereas the data nodes, which only keeping the data, are termed as the slave. Now let us go through some of the basic operations of NameNode as well as the data node. NameNode maintains and manages the data nodes and assigns the task to them. So as I just explained, giving that manager team member interaction, right? So whenever a read-write operation is being induced upon the Hadoop cluster, the NameNode will take care of it first. NameNode will allocate the blocks. NameNode will create the replicas, and then the data will be put into the data nodes. NameNode doesn't contain the actual data of files. NameNode stores metadata of actual data, like the file name, path, number of data blocks, block location, etc. NameNode manages all the request, read, write of client of actual data file. NameNode executes file namespace operations like opening, closing files, renaming files, and directories. So if I want to modify any file or directory inside the Hadoop cluster, obviously NameNode will allow it or instruct it first, then only this will happen. So each and every operation that the client or me trying to put into will go via NameNode only. Once the NameNode allows, then only the data node will carry out the same operation. Now, some of the basic operations of data nodes are: it is responsible for storing the actual data. Upon instruction for NameNode, it performs operations like creation, replication, deletion of data blocks. When one data node gets down, then it will not make any effect on the Hadoop cluster due to replication, which I just mentioned. It's one of the properties of the Hadoop cluster, which is termed as the fault tolerance. All data nodes are synchronized in Hadoop cluster in a way that they can communicate with each other for various operations. Now, one thing to remember over here, that the data nodes are not only communicating with each other, but it's also communicating with the name node as well. And based on that, name node can understand what are the data nodes that are up and running. If it doesn't get any signal or heartbeat, which is sort of an acknowledgement from any data node frequently, in that case, name node deems that data node to be failed or down. In that case, that data node won't be considered for writing or reading operation at all. So these are the basic operations of data node and name node, and how it interacts with each other in the Hadoop cluster. Stay tuned and reach out to TechSpark for more. We cover all the necessary tools in our data engineering course, such as Spark, Hadoop, Hive, AWS, with hands-on coding and real-world project. See you on the next session. For the moment, bye-bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.